Hello students, this is Mitra. Going to start ITF. Some more properties on ITF. Property number 2. Property number 2. In this one, we will discuss about the property that sine inverse sine x equals to x, an x element of closed interval minus pi by 2 to pi by 2. Second property, cos inverse cos x equals to x, again x element of closed interval 0 to pi. Now tan inverse tan x equals to x, an x element of minus pi by 2 to pi by 2. Fourth property, cot inverse cot x equals to x, fx element of 0 to pi. Now next, sec inverse sec x equals to x, fx element of closed interval 0 to pi by 2 union pi by 2 comma pi. Now next one, for cosec inverse x, cosec inverse cosec x equals to x, fx element of closed interval minus pi by 2 comma 0 union 0 comma pi by 2. Now these are the properties. We have already studied about the first property about the sine of sine inverse x equals to x for some condition, cos of cos inverse x equal to x for some condition, tan of tan inverse x equal to x for some condition. Similarly we have studied. Now we are going to study sine inverse sine x equals to x. Sine inverse sine x equal to x if x element of minus pi by 2 to pi by 2. Cos inverse cos x equal to x if x element of 0 to pi. Tan inverse tan x equals to x if x element of minus pi by 2 to pi by 2. Cot inverse cot x equals to x if x element of 0 to pi. Sec inverse sec x equals to x if x element of 0 to pi by 2 union pi by 2 to pi. You must take care in mind that the open, here we have used the open interval and here it is closed interval. Cosec inverse cosec x equal to x if x element of minus pi by 2 comma 0 union 0 comma pi by 2. These are the properties you must keep in mind with their condition. Without condition, properties are worthless. Now we will see the proof of any one of them, and the rest of the proof will be done by you. Suppose I am taking the first one, then sine x proof sine inverse sine x equals to x. Now we are assuming that let sine x equals to y. What we will get, we will find that x equals to sine inverse y. Now we will get a condition that if x equals to sine inverse, and on the place of y we can put sine x sine inverse sine x equals to x. So we have fulfilled the condition. Thus we can say that sine inverse sine x equals to x for all x element of minus pi by 2 comma pi by 2 in closed interval. Now one more property we will discuss. Rest of the proof will be done by you. If you have any doubt regarding anyone, you can put in the comment section so that I will discuss. property number 3. And now in property 3, what we will understand that sine inverse minus of x equals to minus sine inverse x, minus sine inverse x. Sine inverse minus x equals to minus sine inverse x for mod x less than equals to 1. Cos inverse minus x equals to pi minus cos inverse x, pi minus cos inverse x or mod x less than equals to 1. Third one, tan inverse minus of x equals to minus tan inverse x, minus tan inverse x or x element of R. Cot inverse minus of x equals to pi minus cot inverse x for x element of R. Cosec inverse minus of x equals to minus cosec inverse x, minus cosec inverse x for all mod x greater than equals to 1. And one more we have left, sec inverse minus of x equals to pi minus sec inverse x for all mod x greater than equals to 1. These are the properties. The sine inverse minus of x equals to minus sine inverse x for mod x less than equals to 1. Cos inverse minus of x equals to pi minus cos inverse x for mod x less than equals to 1. Tan inverse minus of x equals to minus of tan inverse x for x element of R. Cot inverse minus of x equals to pi minus cot inverse x for x element of R. Cosec inverse minus x equals to minus cosec inverse x for mod x greater than equals to 1. Sec inverse minus of x equals to pi minus sec inverse x for mod x greater than equals to 1. These are some properties you have to keep in mind with the conditions, and we will see the proof of any one of them. Now if we are discussing the proof of first one, proof sine inverse minus of x equals to minus sine inverse x. Now we are assuming that if let sine inverse x equals to y, then what we will find? We will find that x equals to sine y, and we know that this condition must be satisfied if and only if that y greater than equals to minus pi by 2 and less than equals to pi by 2. Now if it is a minus, putting minus to both sides, we will get minus x equals to minus of sine y, and what we will find the condition? We will get the condition that pi by 2, that inequality will change and inequality will become greater than equals to minus y greater than equals to pi by 2 negative side. Now this is a new inequality. Now what we got, that minus x equals to minus sine y, and condition changes to minus to positive, pi by 2 greater than equals to minus y greater than equals to minus pi by 2. Now if I am putting this minus y to shift here, that minus x equals to sine of minus of y. Now the variable changes to minus y. What we will get? Again the condition remains same, and the condition becomes minus pi by 2 less than equals to minus y less than equals to pi by 2. The condition remains same. Therefore we can write that sine inverse minus of x equals to minus y, and this implies that keep sine inverse minus of x equals to minus sine inverse x if mod x less than equals to 1. Now what we did, sine inverse minus of x equals to minus sine inverse x, we have to prove this. What we took, sine inverse x equals to y. What we find, that x equals to sine y, and in this y x equals sin y means y is a variable, and this should maintain the condition that y must be greater than equals to minus pi by 2 less than equals to pi by 2. Now if you're multiplying to minus to both the sides, minus x equals to minus sin y, the inequality will also change, because pi by 2 greater than equals to minus y greater than equals to minus pi by 2. Now if variable is minus y, now this variable is substituted here, minus x equals to sine of minus y, and the condition can be written like this, that minus y greater than equals to minus pi by 2 and less than equals to pi by 2. Means what we found, that sine inverse minus x equals to minus y. This implies that sine inverse minus of x equals to y, means sine inverse x minus of sine inverse x when mod x less than equals to 1. If we wish to prove the same condition for the cos inverse x also, now what we will do, now taking one more proof here, cos inverse, second one, cos inverse x. We have the property cos inverse minus of x equals to pi minus cos inverse x, pi minus cos inverse x, and the condition was mod x less than equals to 1. Now what we will do, we'll assume that cos inverse x equals to y implies that x equals to cos y, and this gives the condition that y must be greater than equals to 0 less than equals to pi. Now if we are multiplying to minus to both the sides, minus x equals to minus cos y, and this gives the condition that if multiplying minus to the inequality also, we will find the condition that 0 greater than equals to minus of y greater than equals to minus of pi. Now the condition changes, because minus of x equals to minus cos y, and minus cos y means that the cos of pi minus y, and cos of pi minus y means that the condition becomes, or we can say that this condition can also be written as a pi greater than equals to pi minus y greater than equals to 0. Now condition becomes cos pi minus y, and the cos pi minus y means that implies that condition will be 0 less than equals to pi minus y less than equals to pi. Now the condition changes, cos inverse minus of x implies that pi minus y, and y means implies that cos inverse minus of x equals to pi minus cos inverse x for the condition mod x less than equals to 1. Again you will see once again this proof, cos inverse minus x equals to pi minus cos inverse x for mod x less than equals to 1. Now what we are doing, just we are trying to assume that cos inverse x equals to y implies that x equals to cos y. This means that the variable y changes, y greater than equals to 0 less than equals to pi, y greater than equals to 0 less than equals to pi. This is the condition. Now we will multiply minus to both the sides, minus of x equal to minus cos y. This means the inequality will change, 0 greater than equals to minus y greater than equals to minus pi. Now y becomes negative, means cos y becomes negative, and cos y becomes negative in the second quadrant. That can be written as a pi minus theta. So it is just written here, pi minus y greater than equals to 0 less than equals to pi. And the condition becomes minus x equals to cos of pi minus y, implies that pi minus y greater than equals to 0 less than equal to pi, implies cos inverse minus x equal to pi minus y. This implies that value of y is cos inverse x. It means that cos inverse minus of x equals to pi minus cos inverse x, mod x less than equals to 1. This was our result, and hence proved. Now we will have some more property in the next lecture. Till that, thank you.